right, logarithms. You have to remember that logs are exponents. That's why we entwine this in here with exponents. Logs, and when I say they are exponents, logs always equal exponents, okay? So what we do with logs, we have, let me show you logarithmic form first. If I have log, this is called the base. It's written as a subscript. So log base b of a equals x. Okay, this is logarithmic form. Logarithmic form. And I can easily change that to what we call exponential form. Because b is the base, that's going to be my base. Logs equal exponents, so it's b to the x, and it's going to equal a. Okay. The log goes away. It's the different form. Kind of like rewriting the radical as an exponent, we rewrite the log with exponents also, or vice versa. We use this to solve things like if I had 2 to the x equals 15. Would you know how to solve that?
Yes.
What would you do?
I would plug in the log.
Well, now that you know logs, but I'm talking about before logs. No, you wouldn't know how to solve for a variable in the exponent. But by changing forms, write this in exponential form, what do you get? Log, what's the base?
Log 2.
Base 2 of
15.
equals. So suddenly the equation is solved for x. So it helps us in finding the value of an exponent when we don't know. Okay?
Wait, so is that the whole answer?
Well, I haven't shown you how to find it yet.
Don't you just type log in your calculator?
No.
Yeah.
Your log on your calculator, we'll talk about this in a little bit, but the log on your calculator is a base of 10 only. It's not, doesn't change the base.
Even with my calculator.
All right, so let's practice changing form because the key to being successful with logarithms is being able to change forms fluidly. How about log base 3 of 81? What does that look like in exponential form? Oh, yeah, equals 4, sorry. 3 to the 4th power equals 81. Okay? When I do this with CP, when you're in logarithmic form, as long as the log is written first, whenever you change it, it goes 3 to the 4th power equals 81. It looks like a big E for exponent. So if this is in logarithmic form, now this only works when the log's written first. Like if it said 4 equals log base 3, it wouldn't work, so don't get confused. But if the log is written first, then it's 3 to the 4th power equals 81. It looks like an E. This is exponential form. This is logarithmic form. All right. Let's do another. How about log base 1/4 of 4? Tell me what you think it might equal.
1.
Close. You're very, very, very close.
1/2.
0.
X. That's the same thing as 1/2.
Negative.
Let's think about why this is -1. Write it in exponential form. What's the base? What's the base? What's the exponent? What does a negative exponent do? It flips it. 1/4 flipped would be 4/1. Ah.
Yeah, but I'm kind of like.
Just take a little while.
It will.
Oh!
Write that in logarithmic form.
I got it.
So log, what's the base? of what?
1.
Equals.
0.
You just got to get used to changing form.
4 to the 3. Yeah, can we do a couple more, please?
Yeah.
Wait, and then we're done?
No.
Why would you do that? It was the game.
Change the form. Bless you. What's the base? What's the exponent? What's it equal? Does that make sense? Yeah. Which way you think's harder, from exponential to log or log to exponential to log? Okay. Yes, they do. We're just changing the form. Yeah. Same thing. It's the same thing as whenever we were changing like the third root of x equals x to the 1/3. They had the same value, they're just written a little bit differently. 9 to the 1.
Just 9.
If you flip it, 2 to the 5th power is 32. If it's negative.
You always flip it.
Wait, what?
The negative exponent's gonna flip it.
9 to the 1st equals 9. What does that look like as a logarithm? Log.
1.
What's the base? 9. Of. Remember, logs always equal what? Exponents. So I know it's going to equal whatever the exponent is before I even start. And the base makes sense. Base written real little at the bottom, so the base. So that leaves the only thing left here is to be the other 9. Logs always equal exponents. Always, always. Shh, 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 shh. What does that equal?
1.
How do you write that as a logarithm? Yes, log. How about this one?
Like an exponent over.
What does that equal?
3.
3. Why?
Because
The third. Good job, y'all. The third root of 27 is 3. 3 times 3 times 3 is 27. Write that as a log. Log base of. So the question is going to quickly become, in just a minute, if I gave you this, could you find that?
what is log? What is log?
Exponent. The exponent. It always equals the exponent. Logarithms are, no, they're a number system. They're used a lot, the most, why can't I even get my words out today? Is that Splenda? The Richter scale. The Richter scale that earthquakes are measured on, that's a logarithmic scale. You might want to do Richter scale one day, what? You might be a seismologist.
Yeah, because we have.
That's actually what I'm doing.
All right. Shh. Look at that one. First, I want you to tell me what it equals, then I want you to write it in exponential form. Oh my goodness. What could that equal? 1 over 25.
It's gotta be negative 5.
So you say 1 over 25 to the negative 5th power is 5. I hear negative 1/5. So 1 over 25 to the negative 1/5 equals 5? No.
No, just the negative.
Well, you're right in that I need the negative. You're absolutely right. I do need a negative.
How are we supposed to?
Somebody just said it.
Oh, yeah.
That's recorded on this.
Yeah, I don't get it.
All right, so what's the relationship in 5 and 25?
So it equals negative
5 times 5.
5 times 5 is 25. 5 squared. So I got to go backwards because I'm going from the squared to the square root. Square root's an exponent of 1/2, and the negative flips it over.
You know what?
Excuse me. You said it again.
All right, Miss McGee, before we move on, I need you to explain with these. I thought I had negative exponent. No, I don't.
So all the negative exponent does is flip it. That's it.
Yeah, I know.
So I know that I need to get 125 flipped over because it's going to equal 5. So I need to get it to a whole number. So I know I need a negative exponent. Now the question is, now that's caused it to flip. So now the question is 25 to the what power would give me 5? And whatever that power is, I'm just going to make it negative to flip it.
So do you have to, I have a question. So whenever we're doing this, do we have to like prove that one side equals the other half? Or do we have to like?
You're just
make it?
evaluating right now. Right now, we're just looking, saying, what would this equal?
No, but I mean on the homework.
I haven't gotten there yet.
Like we don't have to
I
write
have a
5
chemistry
equals
test
5.
tomorrow.
We can just leave it like as it.
So we have a test tomorrow.
I have a
Oh,
chemistry.
I have a
So, changing the form is really, really key to being able to evaluate and some other things that we're going to do later. Let's do a couple more before I show you natural logarithm and common log. Evaluate. Tell me what that equals. There is, but I won't show you that till tomorrow.
My calculator does it.
That's right. 4.
Wait, how?
Because the question is, you have to think about it. You have to think about it in exponential form. I need the exponent because logs equal exponent. 3 to the what power gives me 81. What will go in the question mark? 4. So if I change this, if you change it into exponential, does it make a true statement? Is 3 to the 4th 81? Yes, so that is correct.
So we do it like that, we just write it as much as we can in exponential form, and then plug in what numbers we get.
Okay, if we do this with decimals,
No,
we don't know.
there are no.
We need fractions.
That are always gonna be whole numbers.
No fractions.
Well, besides the fraction. Okay.
Evaluate.
I got you.
Okay.
Ella, hi. Let other people work it out.
Actually, no. Wait. No 7. But you're on the right track. It's
I lost my Wait, so we're trying to.
what power do I need to raise 1/4 to get 256? 4 to the 4th power is 256, and yes, it needs to be negative. Guys, I need y'all with me. It needs to be negative to flip the fraction. This one's gonna make you think. Don't whine. This is not whiny Wednesday.
Our brain can't.
Log, all I see.
Oh yeah.
We're not that bad.
Log.
How is that possible?
Ooh, how is it possible?
Negative 1/2? Am I tripping?
Well, to the 1/2 would be the square root of 64, which would be 8. And so that doesn't equal
So
2.
would it have to be
1/4.
like negative, like a negative 4?
1/4, so what's 64 to the 1/4 power? What's the 4th root of 64?
It doesn't work.
It doesn't work.
Would it have to be like a negative or something?
1/8? Close.
1/16. 1/32.
Something 8 though, right?
1 to the 32nd.
Look at your list of powers. Look at your list of powers.
Is it the 1?
2 to the what? 1/4?
You're getting warmer.
3.
4/3.
What's 2 to the 6th power?
That's what I was trying to.
What's 2 to the 6th power?
It's 64.
64. If I want to go backwards, I need to take the root, and the root is a fraction.
Oh, I've been jumping all around.
What's the sixth root of 64?
2.
2.
The sixth root.
Oh my gosh.
Wait, so like the sixth root is the same thing as saying 1/6?
Yes.
So good.
Word, stop.
No.
I agree.
Y'all know this? We're not.
Wills, what's that equal?
Wait, I haven't even read it yet.
2. Wait.
36 squared is 6.
36 1/2.
Oh,
Negative 1/2. Alright, that was pretty close.
How about positive 1/2?
I don't get a chance to even like think about it.
Okay, I'll give you one and everybody be quiet. Okay, you have to think about it.
Wait, why is it 1/2?
All right, it's 1/2 because it's a square root. The square root of 36 is 6, so to do a square root, it's 1/2. 36 to the what power gives you 6.
That's the same thing.
It's all about being able to fluidly change those forms.
So if you like start saying like, oh, that's the square root of this number.
Yes. Third root would be 1/3. In general, if your number is getting smaller and it's still a whole number, you're going to be talking about a fraction. If you're going from fraction to whole number to fraction, you're going to be talking about a negative exponent. Let me get a good one. Oh, this is a real good one. Nobody blurt the answer when you get it.
Yeah, I mean, I think most cases.
That's a point.
Oh.
Oh, I thought y'all liked decimals. We love decimals. Take a minute. My first question for those of you who are stumped, so you stand a chance of finding the right answer here, is what is 0.001 as a fraction? 1 over 1,000. Now try to find the exponent. Okay, go, Wills.
10 to the 10th power times -3.
I'm sorry, I made it
That's right.
I got
That's
1
right, that's
over.
the same thing that we did in
Oh, I said the negative
right.
100. I don't even remember this.
I got the 10 for it, but
Oh, no, that's what I got.
Wait,
I have it right.
That's what I got. That's what I got.
This is 3-0.
See, I had the 3 part. But I don't understand.
All right, look, let me help you. Let me help you how you're going to think through this when you see it, okay? My base is 10. I'm looking for my exponent. It has to equal 1 over 1,000. I know that the negative will flip it, right? So the negative's a given. I'm going to have a negative there. I'm just going to put it there. So now my question is, 10 to the what power would give me 1,000? Well, 10 to the second would be 100. 10 to the third is one more 0. So that would be 10 to the third. So I know it's got to be negative in order to flip it, so that would be -3. I told y'all that was a good one. One more try.
Same type of deal.
All right, you'll get this one. I bet you'll get this one. Nobody say it when you get it.
Oh my God.
We did one very similar to this.
I got you, bro.
You got it, Wills?
Yeah.
Hold on. I'll let you answer when the time has come. There's still some smoke coming out of a few ears here. Wills!
-5.
No.
Are you kidding?
Okay, listen, here's what you're doing. You're multiplying it by that instead of exponentiating it.
Yeah, well, no.
5 to the 5th power, where's your exponent sheet? 5 to the 5th power is a huge number.
Oh, it's -2.
Go up one more.
Can we do it now one more?
You're,
Oh, so I'm looking at the sheet and
Alright, I don't like it. May not be a math person.
you're thinking right, Wills. You're coming out. You're just multiplying instead of raising it to an exponent. So what you need to think is, so you said 5, right? Because times 5. No, that doesn't work.
I don't know what I was thinking.
I kind of just like.
One more? I keep saying one more.
Well, okay, when are we gonna stop?
All right, 12 more?
When I feel like everybody's good, I don't feel like everybody's good.
Let me answer this one, all right?
I think I already know. I knew after I said it.
I got the answer.
What is it?
5. Yeah.
That was an easy one.
Nah, it wasn't. It's been easier than the ones that we've been doing.
It's all David's fault.
Let me see somebody's. Let me see.
Oh, I saw this. Oh, I knew it.
Don't blurt it out if you get it. Don't blurt it out if you get it.
Oh my gosh, Nancy.
Well, when he was in Charlotte.
When you find nothing, no, I'm just trying to do the problem.
What problem?
All right, don't blurt this one out. This is a good one. Tell me what you got. Ooh,
I got negative 1/3.
that's what I got too. Okay, so how? Let's reason through it. 729 to the what power gives me 1/9? I already know it's going to be negative. I need to flip it over, right? All right, so negative, I'm just going to put in there, and I'm going to say, okay, so what do I need to do to 729 to get it to 9? It's getting smaller, so I got to do some root. Well, square root's not going to get there. What about third root? Yes, the third root of 729 is in fact 9.
See, I just need 6. Oh, 3 to 6 probably.
You got to look at what your base is and what it's going to equal. So it's got to get back to a 9 base. Tell me what you think.
You know, just let me just do some work and then
Like, isn't there?
All right, let me show you a couple little things. I know, that's because we had that big old drill. I'm going to have to find, this is not enough practice with these. All right, so we have different types of logs. Logs. The first type that we have. Hey. Yeah. Common log. A common log is a base of 10. It always has a base of 10. That's what your calculator does, okay? So if there's not a base indicated, in other words, if I said log of 100, you would know that really what that is log base 10 of 100. And for this one you could, well, you know that log base 10 of 100 is what? 2. And so if you were to take your calculator and type log 100, you would see that it gives you 2. Okay.
My calculator doesn't call it.
Okay. No, it'll do. It'll do. I'll have to show you how to do it. All right, so just like with a square root, if there's no root indicated on the radical, it's an imaginary 2. If there's no base indicated on the log, it's a base of 10. Okay, common log. Now, ironically enough, a common log is not the most common log there is. The most common is what we call a natural log. Natural log. And a natural log has a base. Can anybody guess?
1. 27.
A, N,
Oh!
E.
Okay, so it's base E,
Oh,
but
that's
it's
what ours is.
written, that is on your calculator actually, because a log base E is actually written as LN. That's not a 1, that's an L, so LN. So there is an LN button on your calculator, and that is the natural log button.
It's right under log.
It looks like log natural. Guess me, my brain's
Wait, Miss Mickey, where is it? Oh, I see it.
Natural log, so it's conveniently enough, it's right there associated with the E variable that we've been doing. Y'all see it? All right. Yes, those are the only two we're going to talk about. And we'll do more with them in later sections. This is kind of an intro to log sections. We're going to kind of do an overview of several things in this section before, and then we'll delve a little bit deeper through the rest of the chapter. All right, log properties. There's two properties that you need to be familiar with, and they really make sense when you think about them. The first one is if you have a base here, and your number or your value here is the same, this just equals X. It always will. And if you think about it, it makes sense, because if you were just given this and you were asked what does it equal, well, you would say b to the what power gives me b to the x. What will go where your question mark is? X.
Wait, why is there like a double base going on?
If they're the same, if those two numbers are the same, so if you had log base 2 of 2 to the 5th, this simplifies to just 5.
So we're gonna have something that goes like that?
Mm-hmm.
I figured that was gonna
So does that mean that,
Oh, so the answer is just what the X is?
The answer is whatever this exponent is goes here, if these two numbers are the same.
Your marker changed colors.
I changed it, yeah.
This is the
No,
one.
no, no,
This
no,
is the
no.
most useless I've ever felt.
Why?
I have the green goes, he's a little at the top.
Where?
Maybe it's just my angle. Or I'm colorblind. I'm definitely not colorblind, but it looks blue.
under the B?
If I had, this is where it's a little more helpful. If I had log base 5 of 25 to the x,
Would it be 25? I mean, 5?
well, 25 is the same thing as 5 squared, right?
2.
So if I could make the base, remember when we were forcing the same base? Or you could always come back and think about it the same way that we have been simplifying, and that is 5 to the what power gives me 25 to the x.
Wait, why do you have to put an X in it too?
Because this one has one. It's written with one.
Wait, so our exponent has an exponent?
It could, yes. Oh, I'm going to go with my gut and feel like that I'm going to do this property again tomorrow and the next property, and I'm